My dear students, welcome to the today's class. The today's class about the Urey-Miller simulation experiment or Miller-Urey experiment, or this experiment only we are called as experimental evidence of chemical evolution. We last video discussed the chemical evolution. That chemical evolution is the experimentally the proved that is Urey-Miller simulation experiment. So why this is called as Urey-Miller experiment? What is happening that in the year of 1953, the student of Stanley Miller is a student of Harold Urey. Here the Stanley Miller is a student of Harold Urey, is a graduate student of Harold Urey. Both the people who conducted the experiment in the year of 1953. But actually they conducted in 1952, but they published in 1953. That's why we are considered as the 1953 only, the Stanley Miller or Urey-Miller simulation experiment. What is the meaning of the simulation? Why should keep here the simulation? The simulation means here the just prediction only, just imagination, just prediction in through this experiment. That's why it is called the Urey-Miller simulation experiment in the year of 1953. The year is a very, very important that. Then come to the year. This is the once observed that the experiment of Urey-Miller. But in entrance examination and the PU board, they will ask just the labeling with the diagram, the 5 marks question, as well as the labeling they will ask in NEET exam also. See here that the first year that is the gases, the electrode, the spark discharges, condenser, boiling water, vacuum pump, and water droplets. These all are the parts of Urey-Miller experiment. So what explained the Urey-Miller experiment? There early earth which is the conditions is there, like that conditions or the resemble condition is created the Urey-Miller in this experimental setup, which is the previous, which is there, like that they are created. But we know that the life is originated in the water. The life is originated in the water. But here he took that. That's why he took the two main important thing that the one is here in the experimental setup. One is the water. This is the water setup, and the another one is the gaseous setup. The water setup, another one is the gaseous setup. So here the one thing that first what he took the in a operator in a boiling water. He took the boiling water. After the taking the boiling water, it is connected to the vacuum pump is there. It is not important for exam purpose. Then this after the boiling that which is the evaporation is there. That evaporation to reach to the spark discharges. In the spark discharge, we have to take the electrodes. What are the electrodes? There is a positive and a negative electrodes. The positive and the negative electrodes. The positive and negative electrodes, and in the setup, he took the gases. What are the gases? The methane, ammonia, and hydrogen, and the water also is there, but we didn't consider because here we took the water. So here the three gases, but methane, ammonia, and hydrogen. This gases ratio is a very, very important for the entrance examination. What is that? 2:1:2. 2:1:2. Ammonia means alphabet is A, so alphabet letter is 1. So 2:1:2. 2:1:2. 2:1:2 is the ratio of which one? The methane, ammonia, and hydrogen gases in the spark discharge. In this electrodes, the positive is that what is electrodes? how much volt of energy they can observe? There is a 77,500 volts. How can it is a divide energy? Divide energy. Divide energy means they can get the energy from the solar, like during the thunderbolt, taking from the ultraviolet rays. Then how much is the 7,500 volts? It is also very important. How much? 7,500 volts. Then it is the temperature is the 800 degrees centigrade temperature. It is also very important in the previous question. 800 degrees centigrade that. So after like this, the down it kept the condenser that. What happened that here when the after the evaporation of the water, the evaporate water droplets can be to reach it to the gases to the in the gaseous chamber, this the spark mutual chamber. That here the gases which is when they will evaporate water to reach the air, what is happening that the gases it is after combining it is help to the organic compound can be converted into inorganic compounds can be converted into organic compounds when it is reached to the spark discharge. See that here the how it is appeared like this. It is appeared like a prebiotic soup, hot dilute soup. Prebiotic soup or hot dilute soup. According to the conservative theory, prebiotic soup or hot dilute soup. Here the form the prebiotic finally or hot dilute soup that. So when the here the reach that here the to form the then it is reached to the down in the condenser. In the condenser to form the water droplets. Which is the water droplet is there that is called as conservates. Which is the water droplets is there. This is called as the conservates. The conservate is there. It is help to the formation of the further steps. But what is the conservate? There is a don't have the any type of the membrane. For example, you can take the water. In the water, when we are add the oil, what happen? Oil can be above like appear like a droplets. So like that here also water droplets. Which one that is a conservates. To form the word conservate, there is no external membrane in the conservates. There is no external membrane to the conservates. Then after that, these here that to reach the condenser, then after the condenser there is a form the number of organic compounds. Like the monomers become a polymers. Number of organic compounds, which is like the number of organic compounds from. Then it is reached to here the organic compounds, then form the amino acids, the next glycerol, number of amino acids together to form the proteins, glycerol and fatty acid to combine together to form the fats. Then again the number of the nucleic acid, ribonucleic acid, deoxyribonucleic acid, it is also formed that. When the formation of the deoxyribonucleic acid and the ribonucleic acid, one of the historical movement for formation of the living organism that. But here finally it is looking like a hot dilute soup or prebiotic soup. It is the prebiotic soup is a word is introduced by Walden. Very important. The prebiotic soup is introduced by prebiotic soup is word introduced by Halden. Halden introduced the prebiotic soup. Then from the prebiotic soup, then to form the what protocell. Then protocell to again remain the other cells will form. It is another topic that this about the total the experimental evidence of chemical evolution, and it is called Urey Miller simulation experiment about this all that when it is 1953. Along with that, here the observed one thing that in the order dilute, one other important that he observed the formation of some amino acids like which one Og. What is Og? A means alanine, very important. The previous lead question is aspartic acid, then again glutamic acid. That these three acid will be formed this where in the water, in the containing the water compound, this organic compound that. So like that he observed, this is very important that. But what happened that Urey Miller, same experiment is done, but without the electrodes, without any energy, without electrodes. Same the experiment is done by the Urey and Miller, but there is no significant result. There is no significant results. If this is there, the electrodes and energy, there is a significant result is observed by the Urey Miller, both the scientists in the year of 1953. This is also previous lead question, and the ratio is a 2:1:2 is a very important. The temperature 800 degrees centigrade. The volts is the 7500 volts is the boiling water. This is a very important labeling and each and everything there. So this is about the Urey Miller experiment. Any doubt? Comment, keep the comments, and thank you the one and all.